Alright guys, this is your next question from Cat24, the first lot. You can pause the video and try it once and resume for the solution. Okay, beautiful question. Consider two sets. The first set is A containing 2, 3, 5, 7, 11, 13, and second set B containing 1, 8 and 27. Let f be a function from A to B such that for every element small b in the set B, there is at least one element small a in the set A such that f of A is equal to B. Then the total number of such functions f is. Now, the point we have to understand here is if you want a function f from A to B such that f of A is equal to B, and for every element in B, there is at least one element in A. That means we basically want onto functions from A to B. In onto functions, the range of the function is same as the codomain. Right? In this case, the codomain is consisting of elements 1, 8 and 27. The range should also be 1, 8 and 27. As per the question, for every element small b in the set B, there is at least one element small a in the set A. Right? So the range should be equal to the codomain. Right? And that means we basically want onto functions. Okay. So let's represent these two sets diagrammatically first. Now, every element in set A has to correspond to some element in set B, exactly one element in set B, right? It can't correspond to more than one element. In that case, it won't be a function in the first place. So every element in set A will have three choices to correspond in set B, right? So the element 2 has three choices. You can write 2, 1 or 2, 8 or 2, 27, right? Same for the element 3 in set A. 3 could correspond to either 1 or 8 or 27, right? So you could write 3, 1, 3 corresponding to 1, or 3 corresponding to 8, or 3 corresponding to 27, any of these, right? So element 3 also has 3 options. Same for the element 5. 5 will also have 3 options. 5, 1, 5, 8, 5, 27. Same for the element 7 will have 3 options. 7, 1, 7, 8, 7, 27. And same for the other two also. So guys, every element in set A has 3 options, and for every element that you choose, the other elements will have 3 choices also. So total number of ways of creating functions from A to B will be 3 into 3 into 3 into 3 into 3 into 3. This becomes 3 raised to the power 6, and that is 729. So firstly, how many functions are possible from A to B? The number is 729. So I have made note of this towards the right hand side. Now the next part is we want onto functions. That means no number should be left out in the codomain. You cannot leave any one of them. You cannot leave 1 or 8 or 27. Every number or every element in the codomain should have at least one correspondence in the domain. As in the question, every element in capital B should have one correspondence in capital A, right? So we must not leave any of the numbers in the set B. So now let's eliminate all the possibilities where we are leaving one or more elements in set B. So now let's eliminate all the possibilities where we are excluding one or more elements in B. Let's suppose I exclude the number 1 from B. So let's consider all the elements in set A are corresponding to either 8 or 27. In that case, every element in set A will have only 2 choices, either 8 or 27. So the number 2 in set A will have only 2 choices, 8 or 27. So you can only write 2, 8 and 2, 27. Same for the element 3. 3 will also have 2 choices, 3, 8 and 3, 27. Like that, every element in set A will have 2 choices, right? So 2 into 2 into 2, 6 times, I could create 2 raised to 6 functions excluding 1. Now guys, we can apply the exact same logic and create functions excluding the number 8. So there will also be 2 raised to 6 in number. And similarly, we can create functions excluding the number 27. In that case, we will have 2 raised to 6 functions again. So you can either skip 1 or skip 8 or skip 27. The total number of functions that we have to exclude will be 2 raised to 6 plus 2 raised to 6 plus 2 raised to 6. That is 64 plus 64 plus 64, 192. So from 729, I will first of all exclude these 192 functions where every element corresponds to only 2 elements. So 729 minus 192, 9 minus 2 is 7. This will be 12 minus 9, that is 3. And you will have 6 minus 1, and that is 5. So we have got 537. Now many people hurriedly mark the second option as the answer, but that's the deadly pitfall that we have here. Guys, we took the first possibility that we are excluding 1. If we exclude 1, the number 2 in the set A could correspond to 8 or 27. Same for the number 3, same for the number 5, same for every other element in A, right? Now in this we will have a special case where every element in A corresponds to only the number 8, or every element in set A would correspond to only 27, right? Okay, these two functions are basically many one functions. Similarly, if we exclude the number 8 in the codomain, we will have exactly two many one functions where every element in A corresponds to only the number 1 in set B, or it corresponds to the number 27 in set B. So once again, we have exactly two such functions. Okay, all the terms corresponding to the number 1 or all the terms corresponding to 27. And similarly, if we exclude 27, we have exactly two many one functions where all the elements in set A correspond to either only 1 or they correspond to either only 8, right? So two functions exactly where all the terms correspond to either 1 or all the terms correspond to exactly one element, that is 8. And now you will notice that in the 192 sets that we have removed, we have counted these sets exactly twice. All the elements corresponding to the number 1, okay, and all the elements corresponding to number 1 again. We have counted for both the cases when we excluded 8 and 27. Similarly, all elements corresponding to the number 8 and all elements corresponding to the number 8, we have counted them twice in the cases where we excluded 1 and 27 both. Similarly, all numbers corresponding to 27 and all numbers corresponding to 27, we have counted these two again twice when we have excluded 8 and 1 respectively. So these three functions, all corresponding to 1 or 8 or 27, these three functions have been subtracted twice. And since all these three functions have been subtracted twice, I have to simply add a 3 to get the correct answer to the question. The correct answer should be 537 plus 3, 540. 540 is the correct answer to our question. That's the first option. So if you ask me, yes, it's a difficult question. And especially because of this pitfall, 90% people would have marked 537. But don't miss out on the fact that these three functions, you are subtracting them twice. So we add them exactly once to get the final answer, 540.